Okay, now let us talk about question 5. Okay, now for the first one, right, A, right, the hint that they actually gave you, right, is actually lies around right here, decomposes similar to group 2 carbonates. So therefore, what you're going to form is you're going to form the oxide, the metal oxide, and then you're going to form the carbon dioxide. Okay, so the whole of this equation, 1 mark. Okay, now for the second question, right, they talk about the keyword. I want you guys to observe right here for B. It is that they say decompose when heated. Okay, decompose when heated. Now, copper 2 nitrate decomposes at a lower temperature. So this is talking about the decomposition of nitrates and carbonates. But instead of going down the group, it's asking you to compare between a transition element nitrate and a group 2 nitrate. Now, although it's a little bit different from what you studied, but the same idea remains. Okay, so now, what is the main idea of why copper 2 nitrate decomposes at a lower temperature? Copper 2 ion has a smaller ionic radius. Okay, or the charge density of copper 2 is larger. I like to often use ionic radius and charge density together because I do not know when they will give me 2 points for 1 mark. That sort of situation. So therefore I prefer write both talk about ionic radius and charge density. Okay. Now so some of you may have written there, right? Going down the group, the ionic radius is smaller. Okay. Now or bigger. Unfortunately, that cannot be accepted because copper and barium are not in the same group. Okay. Now, so that is your 1 mark. The second mark is that because copper 2 has the larger charge density or smaller ionic radius, it is able to polarize the nitrate ion more. But the keyword you want to put right there is ionization, ion polarizations. No, sorry, not ionization, it's polarization. It's able to ion polarize the nitrate ion, weakening the NO bond inside the nitrate ion. That's the key one they want to see. So the keyword right there is polarize. And you must often, because of this is a comparison question, right? You often need to say copper 2 is able to polarize more than the barium ion. Okay. Okay. Now for this next question, sometimes sometimes the mark scheme they like to do shortcut. So I sometimes it can make it very confusing. I like to make it the long step. So because of this is from, we start from reaction 2. This part right here okay, is calculated from reaction 2. Okay, this part right here is calculated from reaction 2. This part right here, right, is calculated from reaction 1. So this what I did right is I do it step by step. So because they give me the S2O3 2 minus, first I find the moles of it. Okay, then from reaction 2, right, the ratio of S2O3 2 minus to I2 is 2 to 1. So times 1 divided by 2. I find the moles of I2 that reacted. The moles of I2 that reacted came from where? Came from reaction 1. So they are the same. So now we are now looking at reaction 1. So the moles of copper 2 plus in 25 centimeter cube solution is moles of I2 times 2 because of the 2 to 1 ratio. Then you get this particular answer. Therefore, the last one is the concentration of copper 2 plus. Remember, need to divide by 0.025 because this copper 2 plus is 25 centimeter of solution, and that's how you get the answer 0.134, 3 significant figures. Now, and the last one, why is it starch? Please do remember, because it's iodine. The minute there is excess iodine, what happens is starch reacts with iodine to form blue-black solution. There you have it. That's why the only suitable indicator for it cannot be anything else other than starch. It cannot be anything else other than starch. With that being said, that is it for question 5 for the trial exam paper 4.